All right, today I'm going to go over the Cooties Outbreak Worksheet. So basically, you're going to get points for completing the worksheet the way we're doing it. I'm giving you the answers. So you just got to do that. Now, I've had some people ask me how to turn stuff in. You can take a picture of the stuff that you write on, email it to me. That's fine. You can uh, just upload that document to your Google Drive and share it to me. I had somebody turn in they edited the PDF and wrote on the PDF. That's totally fine. Um, you can write it on notebook paper or computer paper or scrap paper or something. Take a picture of it, send it to me, however you want to turn it in. I'm still working out how things show up to you guys when stuff turns in, so we'll kind of play around with that too. But right now, we're just going to focus on this worksheet, okay? All right, so Cooties Outbreak, I just thought this would be really relevant to what's going on right now. So it's just a kind of way to get some general data, use that to kind of show how we're going to do it. And then actually what we're going to do tomorrow is we're going to use real data based on the coronavirus. So the Cooties Outbreak is kind of like a generic version, and then we'll do like what's actually going on right now with this. So it was an ordinary day. It was an ordinary day. It was. Then came the screams. Cooties. He gave me cooties. This was soon followed by cooties. She gave me cooties. Soon classes began to fall all over, still breathing, but in an unconscious state. Bodies started turning blue and pink. A contagion was among them. The teachers who have to receive cooties immunizations to get their licensure were left stunned. Everyone thought Cooties was fake, but no more. After infected boys made contact with girls, they received the disease. When the infected girls made contact with the boys, they received the disease. It was decided that a quarantine and a lockdown were essential. Although the 800 students at Swag High School wanted to head for the doors, they realized that they could spread the virus to the entire city of Swagtown before long. Hashtag Swag Cooties was trending internationally. Fortunately, you were locked in a classroom with your favorite math teacher. To pass the time, they decided it was a great opportunity to explore mathematical modeling. Lucky you, every 10 minutes your class is getting text updates for how many infected students there are. All right, so the first thing we're going to do is pretty easy. We're just going to make this graph. Now, so I'm just going to I'm going to make XY charts. I mean, not XY, I'm going to make my axes. So it doesn't really matter exactly how you do it. We'll just kind of go like this. So I'm just doing my best to make a nice straight line. So the x-axis right there, left and right, that's going to be minutes. The y-axis, that's going to be number of infected people. So that's the number of infected people. So I'm going to make my XY chart. I'm going to my x-axis go by fives. Now I really don't want to like actually draw that every 5. So every 2 I'll put 10. Now if I was I kind of want my data to kind of fit in this because we're going to use just it visually to kind of give us a clue. And they're actually going to use a website to kind of help us get the equation in line and stuff like that. If I was going to gather more data later, I would make sure that my x-axis could go further than 90. I'd make sure, because then I might use the actual, I might continue to use the graph to guess what's going to happen next and stuff like that. So that's what we're going to kind of, but we're not going to do it that way exactly. So I'm going to make my y-axis go by 25. So every little dash is 25. I'm only going to write up the hundreds though, because it'll kind of congest everything. So this is just a way to make it a little bit cleaner looking. So every 4 is 100, which will make it, like I said, look a little bit nicer. And now I'm just going to plot my points. So this is basically your x. This is basically your y. So my first point is going to be 10 for x. So I'm going to go right to 10. I'm going to go up to 5. Well, that's going to be kind of like right here. Now, if you want to start with 0 minutes, there was nobody infected. That's fine too. We're not going to go. That's why we only put this part in the graph, because we're not going back in time. We're not going to have negative time. So we only need the first quadrant of our graph, the positive x's and positive y's. Now 20, I'm going to go up to 9. So 20 is just going to be kind of right there. 30 is going to go up to 18, so we're still not even to 25 yet. 40, we're going to go to 31, so that's just a little bit over. See how it's starting to kind of increase? It's 50, we're going to go up to 65, so now we're making a little bit of a jump. So this is 65. 60, we're going to go all the way up to 110, actually 111, so 100. So right here is 100, so we'll say 111 is kind of like right here. And that's when we start to notice a huge increase. 70, we're going to go up to 235. So I'm actually going to make it a little bit easier. I'm going to go up to 235. I'm going to look at the y-axis first, so 220, 235, right there. And then 80, we're going to go all the way up to 426. So huge, huge increase. Now I'm going to kind of connect my dots. And actually, I'm going to go back. I'm going to connect my dots in a different colored line because this is not a function. This is not a graph per se. This is data. There could be outliers here. Obviously, we are. This is a project where I kind of know the data, and we're going to let that data work. So it is going to kind of fit. But if this is a whole bunch of data, so the red dots are what actually came from our chart. The blue is like the equation of the graph of those dots. But in real data, you might have a bunch. You might have something here. You might have something. You might have way more information, and it just might be that's regression analysis is finding the best graph for that. It's not always just cut and dry, kind of how we had it. So that green stuff is not needed. I was just kind of showing what that does. So they do not need the green stuff. I was just kind of showing. So that's pretty much the graph. Pretty simple. Now the next part's going to be use the graph to plot the points. We did that. What family does it look like? Well, to me, if we remember from our graph the other day, from our chart, to me that looks like an exponential. It's getting really big, really fast. There's no leveling off. It's not coming back down. It's definitely, to me, looks like an exponential. So remember, it gets really big, really fast. All right, so now we're going to kind of do the, we're going to do this back part. This is based on an exponential model for this data. All right, so we looked at it. We thought it was an exponential model. And now we're going to use this idea to create it as an exponential model. So what we're going to do now is I'm just going to open up a browser. So we'll see if this works. I'm trying this. All right, so in the browser, I added the link to our Google Classroom. It's planetcalc.com/5992. I like this website when I used it on my computer. I'm just using it now for the first time on my phone. So we'll see if it's mobile friendly or not. Now what I'm going to do is I'm just going to type in my x values. That's the minute. So I'm going to type 10, then space, then 20, then space, then 30, then space, then 40, then space, then 50, then space, then 60, then space, 70, space, 80, space. All right. So it says make sure they're separated by a space, not a comma. That's something that's a little bit different for some people. Now, look, it says y values separated by space. It already was saying things that don't match up. So it will be red if things don't match up. So now I'm going to do 5, then 9, then 18, because that's the third one, then 31, then 65, then 111, then 235, then 426. Now hopefully after I put 426, things work out. Let's see. Nice. All right. It says x equals 0. I don't know about that. I don't know why it's. So anyhow, I like this one the most because it has a bunch of different regression calculators. They'll do a whole bunch at once. We don't need cubic because we're not talking about that. And we don't need hyperbolic. And why is it saying error? It's annoying. So that's something's making 0 show up. Maybe I had to take away that space. See if that fixed things. Don't. Well, shenanigans. So all of this didn't work perfect for me right now. I'm actually going to open it up in a different application, and the good thing I like that you guys were able to see how to type stuff in. And what I'm probably going to do, what I'm going to do is um, open up my phone's browser and then take some screenshots and show you what happens when it looks in right. So, but you at least got to see how you kind of type stuff in. I got to explain that. So this is not 100% correct because for some reason it's adding a 0 here, which is making this math processing error mess up. So I'll have some correct stuff in a second. All right, so I actually did this all once, and I found out because because I want to use a model you're more comfortable with, that it's really important that we make that right there a 3. All right. I played around with it with a 1, and then with a 2, with a 3, with a 4. You definitely want it as a 3 at the smallest. Like 4 is what they already have set, so if you keep it as a 4, that's fine too. It doesn't really matter which one you use. So the screenshots I'm going to show are going to be with it as 1. I just didn't feel like making new screenshots, so I'll just cross them off and write what I think you're going to end up having. So I'm going to leave it as 4 just because that's what they have by default. But if you did want to make the numbers smaller, like I said, when you round, you become less accurate. And if we're going to use this power method, it's just not going to work out very nicely. So all these, everything's going to really pretty much stay the same. But the numbers are slightly different on your screen. I'm not going to use linear anyhow, and we didn't think we were going to use linear, so I'm not using linear. And here's why. Look at that. Look at that error. Oh, sorry. That error is 287% error. It's not even close. So that we just looking at it, we didn't think the data made a line, and that math supports that. Same thing with a quadratic. We didn't think it made a U or an upside down U. 110% error. So we're not using that either. With this power regression, 39% error, that's not too bad. So if we were stuck, if there's nothing else that works, we would consider power regression. What we're going to find out is that there is better choices than that. But see how like the power regression fits. If I only had these 3 choices, I would 100% pick power regression because that fits way better. All right, so now I get my next page. And it looks a little bit different on your computer, but the same idea. A/B exponential regression. That's kind of what we're calling exponential regression because that's how we like it. And I like exponential regression because look at that, 3.8%. When I look at my when I have it down to 4, it's at 3.77. So that A/B exponential regression and just regular exponential regression both have kind of like are the best. Logarithmic. We're going to talk about why this is scary going forward tomorrow. So we want this, but we can't have it because look at that error. All right, we're going to talk about why we want logarithmic regression or even quadratic regression, but that's not what our data supports right now. Our data supports exponential regression in 1 of 2 ways. I'm going to use this one because it's easier. Now remember, I'm actually going to use what my 4 decimal has because when I did it with 1 decimal place, it was messy. It was not accurate at all. So it's going to be y equals 2.5686 times 1.0659. And then the exponent is going to be x. So notice that's the difference between the... so that's going to be my answer for number 3. We just talked about our answer for number 3. We're going to use the exponential model. I'm using A/B exponential because like I said, the exponential model they're talking about, there are two types of exponential models. One uses the letter, it's a number e. It's kind of like pi. It's a irrational number that goes on forever, and we use e to represent it. Um, I don't think you guys like that as much, and they're both the same amount of error. So I'm gonna use the one that I think you guys would make a little more sense to you. So y equals 2.5686 times 1.0659 to the x. All right. Now, what I'm going to do is I'm going to put 90 in for x. I'm going to plug it in right here. So in my calculator, I'm going to put 2.5686 times 1.0659, and I'm going to put 90 as my exponent. Now, when I did this with 1.1, that's where I noticed a huge error because it was just rounding out. It was just nowhere near accurate. All right, so I got 802, and it's about. So I got about 802. Now, if you used if you used a different model, you might got something slightly different. So that's what I got for 802. Um, Now I'm going to do the same exact thing. This time I'm going to plug in 120. So I'm going to do the same thing. I'm going to plug in 120, and then I'm going to do the same thing and plug in 180. So I plug it in for 120. I end up with about 5,440 infected. And this is why all these precautions are coming up, is look at the huge increase after 180 minutes. So after 180 minutes, I plug it in, and I get about 2,000 or 250,443. It was such a huge jump. I was like checking my numbers multiple times to be like, man, that is crazy that would happen. Based on the model, when 880 students become infected, well, it's obviously going to happen between 802, so a little bit after 802, or after 90 minutes. So we'll say, like, I don't know, like 92 minutes. That's a guess. And the easiest way to guess that would be to finish your chart. Put 90. So to get that, add 90, 802 to your chart. And then if you wanted to add 120 and 5,440. All right. Lastly, do these predictions seem realistic? Well, in number 6, we said there's only 880 students. So if we did quarantine everybody and like we're supposed to, well, then you're never going to get everybody has it. So 100% infection is 880 students, not not more than that. So you're never going to get to 5,440 and 250,443. Now, if it left the school and was not contained, then of course you could get all that. So that's what we're going to do. We're going to talk about some of that stuff tomorrow when we kind of do the same idea, but we're going to do it with our numbers that we've been gathering from the state of Ohio and coronavirus. All right. So that's going to finish your worksheet. Make sure you finish that and turn in. All right. Thanks.